Okay. Again, so this is a question 23, so that's something you want to recognize, but and in a recent AMC. So one thing we want to realize is that it probably involves some sort of smartness, but we definitely want to employ recursion here because when something is like a sequence of something and there's some sort of let's say conditions on it, with like no 2 consecutive this, no 3 consecutive that, things like that can be really identifying to say that, okay, it's recursion. And so what I'm going to do is I'm going to try to crack open a recursive formula for this based on the conditions given. So first off, let's assume we have some sort of thing that starts with a 0, ends with a 0. One thing you have to think about when trying to form a recursive sequence is to see from this point on, how can you form another valid sequence, right? Like by adding things to the end. So, well, I can definitely add a 1 and a 0, and it would work. So it would still end in a 0, start with a 0, and it would also have no 2 1s and no 2 0s, or no 3 1s and no 2 0s. I can also add 1 1 0 because you can have up to 2 1s next to each other. So you can have either no 1s, right? No 1 or 1 1. So if you do that, then you have 2 new sequences. And so if this is of length n, then this is of length n plus 2, and this is of length n plus 3. So obviously you can't define a recursive sequence in terms of, what the future terms. So you have to go backwards. So assume that there's a sequence of length n the other, so I'm just going to assume it's length n plus 3. You can reach a recursive sequence by so the number either ends in 1 0 or it ends in 1 1 0, definitely, right? So you can either chop off the 1 0 and make it or I'm just gonna assume that this is n. Okay. You can either chop off the 1 0 for if it ends with 1 0, and if it ends in 1 1 0, then you chop off the last 3 digits. So in those cases, it would start to match the original. So we can write our recursive sequence as f of n is equal to f of n minus 2 times plus f of n minus 3, because this is for the condition that you chop off. The sequence ends with 1 1 0, and this is for the condition that the sequence ends in 1 0. Or I should technically say 0 1 0 and 0 1 1. Okay, something like that. Okay. So, okay, we have that, but the problem is, where do we start with this recursion? Because if you think about it, for 3 digits, so f of 3 is equal to 1 because there's only one way you can write it, 0 1 0. And then f of 4, again, so before I move on, if you guys didn't understand, f of n is equal to number of valid sequences of length n. Okay. F of 4 is also equal to 1 because there's only one way you could write it. And for f of 5, there's only one again because you can only write it as this. So I think now you could start off with f of 6. And I guess go on from there. So let's try to do that. And for that, I'm just going to define a sort of table up here. And it's going to be n and f of n. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Okay, you know what? We're gonna get rid of the first values. So we're gonna start out with 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. Right, and we already have the value of f of 3, 4, and 5. So f of 6, right, if you look at this, f of 6 is equal to f of 4 plus f of 3. So then that's equal to 1 plus 1 is 2. And f of 7 is equal to f of 5 plus f of 4. So that's f of 5 is equal to 1. F of 4 is also equal to 1, so 2. F of 8 is equal to f of, what is it, 6 plus f of 5. F of 6 is 2, 5 is 1. So if you keep going, what you do is you keep adding these numbers up. So I'm going to just do that live. And 9, 12, 16, 21. So you just keep going because it's not that complicated of an addition. Finding a closed form for this would be a pain. So we're not going to try to do that. So you get 28, you get 37, you get, what is it, 49, and then you get 65. So then our answer is 65. So here we made the choice to not try to find a closed form because our recursion was easy, simple enough for us to, find, just bash it out and write out all the terms. Just make sure that you don't do a silly mistake on the way, because that can affect, it's the domino effect, right? Because if you mess up one, then you mess up everything. So here, I guess the key was so less of bashing it out at the end, but to find the recursion actually. And this can be really useful in a lot of combinatorics problems, which we're bringing up here because it's this type of sequence. But yeah, so that's how you go about doing it. And we'll cover, brief a little bit more about recursion later in combinatorics. So yeah. So let's go to the summary. For a summary, we have that we learned about arithmetic series, geometric series, arithmetic cogeometric series, telescoping, and then random series. And I would actually call these recursive in particular. But there's also random series that you can have that you can try to get a closed form and try to find patterns for. In terms of memorization, in addition to the formulas that we discussed related to AGS and APGP, we want to memorize these as well. The sum of the first n terms, for some of the first n odd integers, so on, similar idea. So these are the ones that you want to memorize. And yeah, so thank you for listening. And if you have any questions, feel free to email me at ananyak.rmc@gmail.com. Bye.